Hello, so we are back, and this time we have an interesting job. I haven't opened the package yet, so I don't know what is inside. It's coming from a local repair shop. So the owner of the shop is saying, customer said the switch inside is shorted. The switch inside are shorted. Okay, so the customer said on this thingy, a switch is shorted. I understood it's like a charger, a battery charger, or I don't know what is this, but looks expensive, huh? This is some car battery starter, or no, it's not charger, it's starter, right? So how do you charge it? Oh, has a battery inside? One second. Pressing the button, nothing happened. Pressing the power on button, nothing happened. Wait, so this is a starter and has the battery inside? I don't know. Let's open. You know what? I don't know what it is. So here are some cables. Clamp output 12 volts, 2000 amps. 2000 amps. You can realize what is that? 2000 amps? That means can easily melt those wires. Pretty interesting stuff. Let's open this and try to figure it out first what it's doing. I mean, I know what it's doing, but I'm not sure if it has a battery inside or not. Yeah, so this is not a battery charger. It's a car starter based on the wire size. Let me get a screwdriver. I'm not sure what screws are there. Lol, you know what screws are there? The Nintendo with 3 fingers. Yeah, I can do it. I can do it. Yeah, I done it. So if you have this to repair, you need a Nintendo screwdriver. You know what? I don't understand how this is working. How this can pull out 12 volts, 2000 amps? I mean, clearly you don't have here a 2000 amps battery. I mean, even a car battery can deliver probably like 800 amps short circuit. So not sure what those people means with 12 volts, 2000 amps. Oh, finally. Finally. So let's open it. No freaking way. 1 second. This has a small battery inside. You know what? I'm really sorry, but doesn't make sense. You know, with my electronics, doesn't make sense. I mean, how this small battery can deliver 2000 amps? I mean, not trying to be funny, even if it's, you know, like high amperage battery, like the RC batteries, let's say has 20 times 20C discharge current. Yeah, so that's mean, let's say this battery has like what? 7 amps, 10 amps. Let's say 10 amps. It doesn't have 10 amps, but let's say 10 amps. 10 amps of 20C is like 200 amps, right? For short period of time. I mean, from 200 amps to like 2000 amps, it's a long way. So, you know, I'm not updated with this, with those things. I haven't repaired before, so I'm not sure. I'm not sure what kind of technology. I mean, if it's a capacitor, like a supercapacitor, it's making sense. So a supercapacitor can deliver insane amount of current. But I don't think it's a capacitor. For me, it looks like a classic battery. Okay, so plus and minus, and actually plus and minus is going through those relays. Let's check the voltage of the battery. So we have plus and we have minus here, and we have 11.4. Okay. So basically the relay are enabling the output. Now, my question is, why this thing is not coming on? Holding down the button and it's not coming on. I mean, even the flashlight is not working. Okay, that's fine, yeah. So somehow this board need plus and minus. Minus, I can see is connected here. Yeah, that's the minus, and plus is here. So we should have voltage which is going to the board. So let's check the voltage which is going to the board. And we have 11.4. So the voltage is present. So why this board is not coming on? Because clearly here is something wrong with the board. In order to fix this, we have to find the problem with the board. Not sure what is this. Let me take out the board. Okay. Freaking finally it's open. You know what? If you have this and you have a job, yeah, just don't take it. It took me like half an hour to open this thingy. This is made to not be opened. Okay, so we have some white things. Not sure if this is liquid damage, but doesn't look like it's liquid damage. Yeah. So it's not looking like a liquid damage job. So I'm assuming this is the power on button. Let's check the voltage on the power button. We should have, like on any laptop, we should have voltage on the power button. So on the power button, we have 0 volts. Yeah, we have nothing. And that's not okay, that's not normal. I mean, I'm assuming this is the power button. 1 second. Yeah, it is the power button. Yeah, this one. So we have no voltage on the power button. Okay, let's follow. I'm assuming it's a common ground. Let's follow the plus wire. So the plus wire is coming where? That's my question. You know what? Actually, let me check the other switches, yeah? This one, nothing, 0. And this one, 0. Yeah, we have no voltage on any switch. Nothing. Okay, so we have the plus here, and we have 11.4. And the plus is going where? That's my question. I think we have to go under the microscope and check. Now, this is how has to be. I mean, what is this thingy? It's like flux, right? Yeah, must be flux. Yeah, must be flux. So plus is coming to this relay, which still doesn't make sense. I mean, okay, but how the electronics is getting powered if the plus is going to the relay? So we have plus here, yeah, and it's coming here, right? And what about here? Here, yeah, we have 11 volts. Here on this transistor, which is clicking the relay. Okay. 1 second. So this is the relay coil here. 11 volts, 11 volts. Okay, so this one is switching the relay to ground, right? Yeah, must be. Yeah, that's what it's doing. That's why we have 11 volts on the both sides. But actually the plus is coming only here. Okay, now I'm confused because I don't know how this is working. That's the thing. Maybe it's working. It's supposed to be connected to a power source, yeah? And on that moment the relay will click. It is possible, but I'm not sure about that. Let me read the manual, yeah? 1 second. Okay, it looks like it will not work if it's not connected to the battery, yeah? So let's connect to our power supply. And it's taking no current, nothing. Okay, let's raise the voltage. 14.5. Let's see what's happening here. And we have, here we have 6 volts, and here we have 11.4. 1 second. So plus is connected to plus, minus is connected exactly here, yeah? I'm coming with a power supply with 14 volts, and it is connected. Minus here, plus here. Why I have 6 volts? Plus, let me get the minus from here. No. So the minus is fine. Minus from here and plus from here, I have 14. So plus here, I have 6 volts. So the plus wire is interrupted, or something wrong is here. I don't know what is here. You can't see, sorry. Here inside of this thingy, something is happening here. Oh, here we have a bunch of MOSFETs. Okay, it's making sense. Okay, it's making sense. So one more time. Minus here, then plus here, and we should have 14, right? And we have 14.7, yeah? So we do have. Okay, power button. We have 6 volts on the power button. Wow. Here we have 0, and here we have 6 volts. So when we are pressing the power button, and the voltage is getting dropped to 6 volts. Wait a second. And what kind of power button is this? You know what? I think the customer is right. So minus, yeah? And we can see the power button has a minus. Now here you have 4 volts. Here you have 6 volts. Here you have 6 volts. And here we have 4 volts. Pressing the power button and nothing happened. 6 volts. Pressing the power button and it's still 6 volts. I mean, what kind of power button is this? Why do I have on one side I have 6 volts and on one side I have 4.5 minus 4.5? 1 second. So here I have plus 6 volts and here I have minus 4.5. Pressing the power button, nothing happened. Same here. Here I have minus 4.5. Pressing the power button, nothing happened. And here I have 6 volts. Pressing the power button, nothing happened. You know what? I believe this customer is right. The the power switch is dead. This one. I can't believe this is some kind of unique case when the customer actually is right. Lol. Okay, so let's check one more time to be sure we don't have voltage there. Yeah, we have nothing now. Now, how we can fix this button? I mean, we can check with the multimeter. Yeah, we can. So with the multimeter, pressing the button is not beeping. I mean, usually you should have a beep when you press the button, like here. Yeah, but this one is dead. Let's fix the button. Let's fix it. How we can fix it? Well, in order to fix it, we have to open. Yeah, let's open the button. Yeah, something like that. Good. Yeah, be a good boy. Be a good boy. Good. Yeah. So the button is open. Good. And we have this thingy there. And you can see oxidation here. You can see it? The green stuff. Yeah. Yeah, that's the problem. That's why this is not working. So let's try to clean it. Let's be sure we are getting the green stuff out. Perfect. Perfect. Good. And we have this to clean. Perfect. Yeah, anyway, we're gonna put this thingy on a different position, yeah? But at least we clean it. That's clean. Perfect. Good. So it is perfect. You agree with me, yeah? So I'm gonna put this thingy, but not like that. I'll put it. Where is it? Where is it? So one more time, I will put this how? Like that. Yeah, perfect. Perfect. Good. Now let's put the button back. This one. Good. Good. And this thingy there. Perfect. It's like new. Check that. It's like new. I mean, nearly like new. Yeah, we're gonna use some. We can melt those thingies with the solder with the solder iron. Yeah, this is not plastic. This is not plastic. Okay, a little bit of hot glue. It will fix the problem. But let's check the switch. Yeah. So the switch here and here. Pressing the button, you can see. Check on the screen. 0 ohms. So it is working. Yeah. We fix it. We fix it. A little bit of hot glue. Just a little bit. Lol, I touched the button. I can't believe. Perfect. perfect. Like new. It is like new or not? Huh? Do you think it will hold for like 3 months? Not more than 4. Okay, it is working. Let's check if the tool actually is working. So let's plug the connectors. Good. Good. So we plugged everything. Plus here. Good. Pressing the button. It is coming on. Check that. You can see the lights. So what is supposed to happen? I mean, how we can test it? I can hear the relay clicking. Because the voltage is too high, let's lower the voltage. Yeah, it's working. Okay, so when you connect the battery, so this means the battery is 75% charged, yeah? So if I'm coming, let's say with a low battery, 8 volts battery, plus here, yeah, it is pushing volt. Check that, it's 11, you can see? So it is pushing current. Actually on the power supply I have only 8 volts. So it is working. I was wondering about the relays, if they are working or not. Okay, what can I say? I'm happy it's working. So this is the torch. This one. Yeah, it's working. The flashlight. Yeah. Okay, I'm happy I fixed it. It's working every time. You can see. So if you have this tool, don't open it. Yeah, it just take like probably like half an hour just to open the screws. It's not meant to be open. But if you have it, the switch, it's getting dodgy. It is a better way instead of opening the switch and actually clean it. Yeah, you can swap it with different switch. You can swap with this one or with the flashlight one. But it's pretty easy just, to open and clean, and that's all. Okay, so I'm gonna stop now. I'll put it all back together by myself. Yeah, I need another half an hour to put it back. But if anyone has more knowledge about this toy, how this toy can deliver 2000 amps, just let me know in the comments, because it doesn't make sense. 2000 amps times 12 volts, like how many watts? 24,000 watts! That's insane! That's crazy. Can't believe. Anyway, let me know, yeah? Thank you for watching, just like, subscribe if you like the video, and see you on the next one. Bye. Băga mea ta. Tu mă, Tisos, cu cine te-a făcut? Design în America și făcut în China, în un căcat. Să-mi bag în el. Dă-o în Paștele, măsii de treabă. Ce căcat e ăsta, mă? Cine a făcut design la căcatul ăsta? Băga mea și de jumătate de oră mă chinui să-l desfac. Pe el să mă îmi bag el. Și în cine l-a făcut?